Okay, let's complete this implementation. What we need to do is, first, we need to define word to ID as a dictionary and ID to word as dictionary like this. And for each word in words, if word is not in word to ID, then it means we need to create a new ID, and we're going to assign the length of the ID as the current length of word to ID. Because the index starts from 0, we can assign this new ID as just the length. And word to ID word equals new ID, and ID to word new ID equals word, like this. And after we construct word to ID and ID to word, we can create corpus very easily. We can use our list comprehension. Or W in words like this. And we can return corpus word ID word. Okay, it's very simple. We can test this together. So let's copy the test case here. And let's see if this is working as you expected. Okay, it prints out the results we expected. All right. Okay, that was very basic pre-processing. There are tons of pre-processing techniques. Okay, we're going to have a look at how we can implement count-based methods first. And after we discuss count-based method implementation, we're going to move on to word vector. Although in the slides, we discussed word vectors first. Okay. Here, we first we'll first implement co-occurrence matrix, occurrence matrix. And what we want to do is implement something like this. It's co-occurrence matrix. We already saw this diagram in the slides. So how can I implement this one? Given a corpus and vocab size, because we need to know the vocab size in advance, because we need to construct a matrix, rows and columns. And to do so, we need to have vocab size. Window size 1, we can change the window size. First, we are going to get the corpus size as the length of corpus. And co-matrix, stampy zeros. Vocab size. And the data type is MP integer 32 bits. Okay. For ID, we're going to enumerate corpus. And for I in range, one window size +1. The reason why it starts from 1 is we don't need to count the co-occurrence between the same word itself. Okay. So what I mean by this is the left index is going to be index minus I. Here, if you don't put 1 here, it could be 0. Then we're going to calculate the count the co-occurrence between the self word. And it is not what we want because the diagonal of this matrix is all 0. Okay, so we want to skip comparing self and self. And right index is ix plus I. And we need to check whether this left index is larger than 0. If that is the case, leftward ID is going to be corpus left IDX, equal matrix, word ID left, word ID incremented 1. And if right index, because it's on the right side, we need to check whether it goes off the corpus. Okay, right word ID is corpus, right IDX, and co-matrix, word ID, right word ID, incremented 1. Then after we count all these numbers, we just return full matrix. So from our corpus, we can create a co-matrix like this. Okay. All right. The next topic is calculating similarities. We're going to talk about cosine similarities. And the equation for cosine similarity is like this. There are given two vectors and epsilon. This is our next QPP exercise. Take some time and implement this function on your own, and see you in the next video.